First of all, guys, very first thing what we do is we just go to the file, rename, and just type sales analysis. Okay, everyone, please, those who have logged in from their laptop, open the Jupyter notebook, open the new notebook, rename the file as sales analytics. All right, rename the file as sales analytics. You can give the title here also, sales analytics. All right, now what we have to do is we are going to study about a sales. Whatever data set that I have given you, that is the real time data set of today. Okay, I have my own company where we also do some marketing. As an effect of marketing, there will be some sales, and the sales of the sales of the data set, and the sales of data set is given to you. Okay, everyone, please open that data set first of all and look into it. You'll find that is only two columns. Serial number is there. Sales of today's day is present. All right, first step what we do is here is we import pandas as usual. Okay, pandas is the library. All right, now this is my library which I have imported. Next thing I have to do is, with the help of pandas, I'm going to import the data set. How I'm going to import data set? In this way. Right, now I just need to copy paste the path. So I will find the path of the file. It's in E drive. What I will do is, all right, in this way my data set will be imported. Everyone clear till this point? I hope this is now easy to all of you. Yes, Vishal, you're trying to say something. Yes, please tell me. Any issues? I hope your doubt is clear. Yes. So what we can do is we just have to now import the file. In this way I will save this file in a data set in some variable. File equals to like this. Okay, now I will print the file. This is my file. Can anyone tell me why this is unnamed 0x? In this way I'm getting the column names. Anyone? Madiha, Disha, Vishnu Prabhu, Sayed Adnan, or anyone others? Why am I getting the column names as unnamed 0x like this? I'm not getting any column names. Correct. So in our original data set, as told by Madhya and Disha, in our original data set only, there are no any column names. So for you, just to give you a real-time analysis, just now before the class, I have downloaded the file, and while downloading, there are any no columns. I just got the details that serial numbers are there and how much sales we have completed in each and every different region. Okay, so that's why. Yes, Vishnu Prabhu, there are no any names for corresponding column. Absolutely correct. All right. So after giving this, what we do is we go ahead with the pre-processing. Yes or no? What we do in the pre-processing? First of all, remove the irrelevant column. Whatever irrelevant columns are there, we will remove that. But here we are not having any kind of irrelevant columns. Only two columns are there: serial number and the news. That's why we will not remove any of the column. Please try to understand. Till now we have removed some of the column. Here we will not remove because there are no any irrelevant columns. All right. Now, if we don't have any irrelevant column, what we do? We check for missing values. Correct or not? This is the syntax for checking missing values. You can just give the comment here, checking missing values. All right. You just have to run this thing. You'll see that there are no any missing values, zero zero missing values are there. You have to comment there are no any missing values. Okay, just one instructions to all of you. If I'm giving you any kind of data set and if you think guys that I should be your mentor, so please 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 always you have to comment in each and every line what you're doing, why you're doing. My all students, I want that they should write a Python script in a very perfect manner. Okay, so everyone who are practicing and who think that you should learn a very good Python programming for data science from me, okay, from data science or business analytics from me, so only requirement is you should always write comments. Why I'm telling this is because now in few days you will start getting your assignments, multiple data set. Okay, you will submit that to me. I want to see that all of you, my students, should write down comments in each and every line what they are doing. So what I will do is, I will not see that what I'm doing here. I will write down only comment, importing library. So I will not see why what is happening here, what not is happening. Okay, here also I will comment importing dataset. All right. In this way, I will do that thing. Now, after having no any missing values, what I need to do is I just need to go ahead and from sklearn library, I need to apply linear regression. Okay, now apply linear regression algorithm. What you need to write down here, import sklearn. Okay, what is this library? This is the library for machine learning algorithms. All right, I hope the things are clear to you guys. This is the machine learning algorithms. Okay, if you want to deal with any kind of machine learning algorithms in future, so that's why we will be importing the sklearn library. With the help of this library, regression problems, classification problem, clustering algorithms, all can be dealt. Okay, maximum possible. Majority of algorithms are imported with this. You will see afterwards in deep learning or in text analytics, you will require different libraries. But for basic algorithms in the machine learning, sklearn library. Okay, so if you're getting Vishal any errors regarding invalid syntax, that means you're not writing as it is whatever I'm writing. There should be some missing dot or bracket, spelling mistake might be there. Okay, wherever you are getting that error, that means spellings are wrong, space are given extra, space are not given, something which is not written as it is. Okay, so let us go ahead till this. Now we have to import simple. We have already seen, that's why I'm going a little bit faster because I want to teach you how to interpret the data. Yes or no? Only analyzing data is not important. You have to also interpret the data. What is happening in the data? What we should do the next after analyzing data that we want to do. Okay. So from sklearn dot model selection. Okay, so from this particular library we need to import a function. All right, anyone having any problem till now? All the things right now is the very basics. All right, it's very basic. So fourth line, this means the first line, second line, display, and then the fourth line where you are talking about missing values. You check this thing, do as it is. From sklearn library model selection, you have to import a function called as train test split. Okay, from this particular library, you're importing a function train test split. From same library, sklearn dot linear model, import linear regression. So this two function, this is my function, this is my function. These two functions are necessary for me to learn with the linear regression. All right, can anyone answer why we need this function train test split? quickly in the chat box why we need train test split quickly, guys. Already we have seen this 2 3 times. We need it for splitting our data set, correct? And linear regression, this particular function we need it for actually applying the linear regression algorithm. Okay, so first of all, whenever you import all these necessary functions, what you need to do is you need to first divide our data set into dependent and independent variable. So you will define x as your variable. Okay, so x is your independent variable. How you will define? File dot iloc. Okay, I hope this syntax I have already shown to you. That's why I'm going a little bit faster. Okay, I'll explain. Don't worry if you need one more time explanation. So let me finish writing the syntax. Okay, what I have done here, I have written down here independent variable and here dependent variable. First of all, what do you mean by independent dependent variables? What do you mean by independent and dependent variables? The variables which are not dependent on any other factor, which are directly stated, they are independent of all of the things. Okay, so and as Revant is telling that yes, he's also telling about independent. Dependent means any variable whose effects or whose results are dependent on another variable, that are dependent variable. Like for example, in our current data set there are two only variables. Okay, one column is about serial number, another column is about sales. My sales I have to predict. This particular data is my independent. This data is about dependent variable. My sales are dependent on some factors, different factors. Right now I'm not considering that, but sales is my dependent factor and serial number is my independent. So same thing, x and y I have defined. Now what I have done here, in my file variable my data set is stored. So file.iloc, with the help of iloc function, I have written that how many rows I want before comma. Okay, before comma, whatever I write it as rows, comma, columns. Okay, all rows I want. For that, I will write colon. And which column I want? Which column I want? I want last but one column. This column I want. For this, I have written colon, which indicates all the column except minus one. Minus one means last column. All the columns except last column. Similarly, in y variable, I have stored all the rows, which is denoted by colon, comma. Which row I want? Only last row I want. That's why minus one. In this way, I've defined my x and y variable, splitting of the data set only into two variables. I have done it. Now, actually, we have to split the data into training and test data set. Right? We have to split in the training and test data. How we have to split? With the help of this function. Alright. So I'll just write down here some variable name like x train, comma y train. I hope you're doing with me, all of you. Yes, you're doing with all of you. Okay, all right. So, hello, am I audible to everyone? All right. Yes. So there was some disturbance. Now it's gone. So x train, x test. We were writing about now y variable. I will write down here y train, comma y test. Okay, in this way I have defined my four different variables. Many students are getting confused in this. Are this variable or are this any kind of function or what? This thing, whatever I have defined here are variable, my four different variable, and I'm going to use this particular function. Okay, this particular function I'm going to use bracket. I'm going to write down my dependent independent variable, test size, Okay, equals to, let's say, only 10%, and then I'm going to write random state equals to 100. Okay, in this way, in this particular step, I have completed splitting of my data into training and test data set. Okay, now actually I am going to import my, I have already imported my linear regression function. I'm going to save it in my small variable, let's say LR. In this way, I'm going to save this function. All right, with the help of now lr.fit function, I'm going to train my data set. So in training, all the training data set will be given. In this way, all the training data set is already given. In this particular line, your model is actually be trained. In this line, data set is trained. All right. Let me know in the chat box. Are we guys clear till the training of the data set? Yes, I hope everyone is doing with me because nothing new I am teaching. Same thing I'm teaching. Just for practice, we are getting new data set and practicing on the new data set. Nothing else. Now we are predicting y variable. Okay, how we predict y variable with the help of predict function. Okay, and whatever we give it in the bracket, whatever we give it in the bracket, that is our input. For x test, we are predicting our values in the y. These are my predicted values. How many total columns are there? Sorry, rows. 200 rows. And I have divided my entire data set into training and test. 10% of data should be in the test data. Means what? 10% of 200. What is 10% of 200? That is 20. So these are my 20 data set, 20 data point, which are into test data. Remaining 90% of my data is the training data, which is used for understanding the behavior of existing sales. So my machine has understood the sales behavior of today's 28th of May 2023, and in this step, after analyzing with the help of predict function in this step, they have tried to predict. And where are my actual values? In the y test function. So these are my actual values and these are my predicted. Means prediction is 13.87, actual value is 10.57. What does this mean? It means that for after analyzing this data, after analyzing data, my machine learning algorithm is telling that sales should be 13.8 for a particular region. For that region, actual value is 10.5. So there is some error. Here also, actual value is 20, predicted is 13.9. Actual value is 16, predicted is 13. You can see that each and every point is different. Only this point is a little bit close. Only one point I saw that it is a little bit close. Actual value is 13.3, predictable value is 13.7, a little bit close. This is also slightly close. This is also a little bit close. But all other values, sorry, this value. Okay. So what does this indicate? What does this indicate? My entire data set is not correctly predicted. Is not correctly predicted, and that's why we need to go ahead and create the accuracy model. First of all, we will try to visualize. We are going to visualize our data set. Okay, so how we are going to visualize the data set means how we are going to know uh, visualize the same thing in the graphical format. For this, we need a library called as import matplotlib dot pyplot as plt. All right, are we guys aware about this library? Have we discussed about this library? Yes, correct. Okay, Vishnu Prabhu, Akash, everyone is telling. I'm going a very slow detailed manner, guys. Every step I'm writing down in front of you. I hope this will be the very useful session for all of you, correct? Okay, Lohita is asking me for explaining once again the predict. It's simple prediction. See, Lohita, what we have done in this step. First of all, what we have done in this step, my entire data set was there. First, I divided entire data set in vertical manner. Vertically, I draw a line and I made two partition, left hand side, right hand side. Left hand side, I named it as X variable. Right hand side, Y variable. In short, I've divided my data set in two parts. But afterwards, I divided my data set in this step in four parts. Training of X variable, test of X variable. Means what? I have divided upper portion, 90% of this variable as training variable. So this is X variable. Okay, upper portion of X variable is called as X train. Lower portion is called as X test. Similarly, Y variable, upper portion is called as Y train. Lower portion is called as Y test. Now, how much upper, how much lower, that we have decided here with the help of test size. 0.10 means 10% of data is in test. Test means lower portion. Okay, so test size is 10%. 10% of what? Entire quantity of rows. 10% of 200 rows are into test data. Okay, above 180 rows are into training. Only 20 rows are into test. In this way, we have first divided into four different variable. Now, whenever I want to teach you something, what I will teach, how I will teach to you, all of you, I will teach you like 2 plus 2, 4 plus 4, 8 plus 8, and I will also give you answers. Correct? Yes, yes, Akash. We can choose whatever test size. I'm going to show you that only. I'm going to show you that only. I am going to today vary my test size, and I will show you what will happen to my data set if I vary my test size. Okay, Akash. Let me explain Lohita till this. So I was explaining that after dividing, what I will do is first I will train my machine. I will train my machine with the help of existing questions and answer. Means what? For this particular serial number, these are sales. Okay, same thing, I've given input with the fit function. I'm training my model. In training model, X train, Y train is given. X train means serial number, Y train means sales value. I'm teaching my machine that if these are the serial number, this should be the sales. These are serial number, this should be the sales. In this way, I am teaching my machine for top 180 rows. After teaching, what I'm doing, with the help of predict function, I'm predicting below 20 rows. For this, what I should give? I should only give serial numbers. Where are the serial number stored? These are serial numbers in the X variable of the tested data. That's why I have given input as X test. Automatically, I will get a prediction. These predictions are nothing but predictions for this value. This value. Okay, the same value are written over here. Okay, so whatever data set is in test variable. Okay, for that we have predicted some values and there are some actual values. Now same thing we are going to visualize. I hope it's clear to you, Rohita. Okay, slowly, if you still are not clear, na, slowly you will understand once you do it by yourself. Okay, 5 6 projects you do it by yourself, you'll understand that thing, what is happening, why it is happening. Okay, now I'm going to plot this thing. What I should do for plotting? First, I have imported a library. This library, this is the library for data visualization in Python. Okay, this is the library for data visualization in the Python. And now, with the help of this library, I'm going to show you how I'm analyzing test, means training data and test data. Okay, first we will draw the scatter plot. Okay, how we will draw that? PLT dot with the help of scatter. Okay, now what values I have to give? I'm going to draw scatter plot for only training data set first. So X train, Y train, X train, comma, Y train. Alright, and let us give some color to this. Let's say red. Alright, so in this way, I'm first I'm first drawing a scatter plot for only training data set. Alright. Similarly, what I will do is just I have now converted my data set into scatter plot. In this line, see, in this line I have converted my data set into scatter plot. I have to actually plot that. So with the help of plot function, now I will actually plot the data set. How I will do? X train, I have to give the input as X train, comma, then I have to use predict function is Y train. Okay, lr dot predict, and here I'm going to write down X test, X train for this particular thing. So carefully listen. In this step, what we are doing is, first of all, we have converted my data set into scatter plot with the first line plt dot scatter. Now we have to plot that. We have we need the graphical representation with the help of plt dot plot. With the help of plt dot plot, I am drawing X train and Y train. Just I am writing Y train in different format. I'm writing Y train in different format. How? I'm writing Y train with the help of predict function. I'm giving input as X train and I'm expecting the predictions for X train values. X train means what? See, in this step, what we have predicted? We have predicted values for X test. This thing is different than whatever I'm plotting right now. Okay, here I have predicted Y variable for X test data set. But here I am predicting sales value for training data set. You will tell me, sir, whatever means what I'm doing here, whatever I'm teaching to the data, same thing I'm predicting. Why I'm doing this thing? To check the training accuracy. There are two different kind of accuracy. One is the training accuracy, test accuracy. For example, if I'm teaching to Vishnu Prabhu, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16. So Vishnu Prabhu told, sir, I understood it. Tomorrow, when I come again to the Vishnu Prabhu and I ask what is 4 plus 4, he didn't answered me correctly. Means what? I have trained him and I'm asking question which is already asked in training only. Still he is not able to understand. Means what? Whatever you are trained, you are not 100% accurate in your training only. If I'm asking you outside the training any question, then 100% you will get the lower accuracy. Correct or not? I'm teaching you something, I'm asking you the same thing, then also if you are not answering correctly, that means your training accuracy is lower. Our expected training accuracy is 100%. What I will expect, whatever I'm teaching to you, at least same data set if you encounter, you should answer me correctly. That is my expectation, means 100% accuracy. But in this line we are going to see that what will be the accuracy, or how accuracy we are getting. Okay, and that we are going to predict by X variable. Say give a color for this. Now how many students did understood this, because this is something new. So please let me know in the chat box if I want to repeat in a different way. If you proceed with this thing and if you didn't understand, it will be not good. Okay, let me know quickly in the chat box. Anyone having any problem? Okay, consider this as entire syllabus that I want to teach to my Python compiler. I will start teaching. I will start teaching that this is question, this is answer, this is question, this is answer. In this way, I will not complete my syllabus. What I will do, I will keep 180 rows, 180 serial number for training, and rest 20 for taking exam of my Python. I will test my Python compiler whether Python is understanding or not. So what I'm doing here is I'm training my model. Where? In this line. If I want to train, means what questions I want to ask. X train, yes or no? Whatever is stored in X in the training data set, that I want to ask. Top 180 rows which are stored in X train variable. These questions I want to ask, and also I want to give them answer. Then only it's called as training, na? If I want to train you about something, I need to give you question also, and I will need to give you answer also. Due to which, what will happen? You will try to understand, correct? Question answers are given to you. You will understand what is the pattern followed, how the answers are coming when the question is asked. This is called as training. But next what will happen now? Training is done. Now I'm asking to my Python compiler, I'm predicting that my Python is predicting that if serial number which are stored in X test are there, what should be the sales value? Why should be what should be my Y variable? Okay, that values, predicted values, I'm storing it in a variable. These are my predicted values and these are actual values, correct? So here whatever I have done prediction, this is for test data. Imagine I don't want to take your exams. What is test data actually? Out of syllabus question. What was syllabus? X train, Y train. This was my actual syllabus which I have taught to you. Test data means it is out of syllabus, which Python compiler has not seen, correct or not? I'm not judging you from out of syllabus question. What I will do, I will tell to my Python compiler that draw a scatter plot first of all. X train, Y train, whatever training data is there, first make entire data set into scatter plot. Then I'm actually plotting that X train values. What are X train? My questions, serial numbers, and predictions of X train only. In previous line I have trained X train, Y train. I have gave you question, I have gave you answers. From this only, from this syllabus only, what I'm asking to my Python compiler now, these are question, what are the answers? I'm expecting prediction from the Python compiler. So whatever I have trained in this particular variable, same thing I'm asking here, same thing. That is called as, that is called as training accuracy. First of all, let us write down here, means there are two different kind of accuracy. First I will mention down here, comment training, visualization of training data set. First of all, visualization of training data set. In this in this we have to write all these things, and then we need to plot it. Okay, how we need to plot extreme, comma. Same, I need to write Y train only, but instead of writing Y train, what I'm going to do is I'm going to predict Y train. So I will write predict with the help of X train only. I'm going to predict the Y train variable. Okay, so with the help of this particular thing, and we will color it with some different color. Let's say blue color. We will do it in the blue color, and we need to run it. Okay, perfect. Yeah, what is the LR predict, sir? So Lavanya is asking, what is LR predict? What is LR? Can you ask me? Can you tell me, Lavanya, what is LR? Where did we define LR? See, LR. What I have stored in LR? My function. Instead of LR, I can also write here linear regression function. How I will write? Linear regression function, entire function. But just to make my life easy, just not to write this word, entire word. What I will do? I have stored my this entire word in small word, small variable. Clear, Lavanya? Perfect. What I have did, instead of writing this much big word, small word. Okay, clear? Means what is this indicating? For zero serial number, okay, for zero serial number, there will be some sales. This is the sale. Which is the sale? Actual sales. And predicted value are indicated by blue. Means same thing, you go ahead and these are my predicted value. Actual value is something this. Means let us consider 12.5 or something. Predicted value is 14 something. Okay, so predict value is 13.8. This is predicted value 13.8. In this way you will see that red spot is actual value. For this predicted value you can see upside. actual value, predicted, actual value, predicted value. And now you can see that this is my training data set. What I have used, training data set. You can see that, sir, what you are trying to convince us is red spots are actual value. Means for the serial number, what is actual sales? Serial number, what is actual sales? And predictions are this. Whenever we are training our model, okay, at least in our training model, we should get accuracy of 99, 100%. But we can see here, that all my actual values are far away from my blue line. This is indicating huge error. The distance between blue line and red spots are my error. Actually, ideally, what I expect is these values which are coinciding, red value and blue value as coinciding, that are my exact predictions, that are my correct predictions. So I'm expecting all the red spots should be on blue line. I'm expecting that, but that are not possible. Why it is not possible? Because set is only scattered. So that's why we should make a conclusion that this particular data set cannot be dealt with simple linear regression. This particular data set cannot be taught to our machine. We cannot use machine learning algorithm which is simple linear regression. This is my conclusion at the end of my code. Yes, we can use a single quote also, Vishnu Prabhu. Not only for color, for any of the string. Are we guys clear till our example, today's example? How I have got a conclusion that sales data is not so suitable. Okay, tomorrow's sales data I will be clear. See what happens in the sales data. What happens in the sales data? Obvious, you will tell me, like Madhya can tell me, sir, sales are not linear, na? Linear things means what? What do you mean by linear thing? It is constantly increasing, decreasing, or it is constant. It behaves in the way of y equals to mx plus c, correct? Y equals to mx plus c. But currently our data set is very much scattered, very much scattered. So we'll write down the comment here that data set is scattered and linear regression is not suitable for this data. Okay, we'll write down this comment. Why I'm writing down this comment? Because on same thing we can apply different algorithm, na? With the help of different algorithms, still we can try to answer our sales. Okay, but we are still clear that in this particular linear regression we cannot answer. Why I'm teaching you this kind of data set? In your life, no one is going to tell you like Madhya, this is the data set and you have to apply simple linear regression. No, no one will tell you. Like Disha, this is the example, or Lavanya, this is the example, and you have to apply. Or Adnan, this is the example, use decision tree. No, no one is going to tell you. You have to decide what you have to apply. Then, with the help of experience, you will understand which algorithm to apply when. At least I gave you few examples that whenever we have a data set which is linear, I will show you example of linear also. See, just 1 minute, I will show you. Let me open a data set. By the way, let me tell you that if we first visualize, currently what we have visualized, training data set. Okay, same thing if we visualize this for test data. Let's say visualization of test data. Okay, how we will do? I will just copy paste this thing. The only changes x train and y train are there, na? Instead of training, test data will be there. Don't worry, I'm going to summarize everything. So if you are fine, see test data. This is my test data. Means what? These are actual value. How much points are there in test data? Only 20. How I have decided? With the help of this 10%. 10% of values of 200 are in my test data. That's why only 20 points should be there. In this also you can see that only one point is very close to my blue line. Test accuracy is also very low. This is my training accuracy. This is my test accuracy. Am I clear with the training and test accuracy? Right. So let me show you another graph. Right, perfect. So, see, this is the graph where you can see that my red spots are very much close. At least it's are slightly close to my blue line. Yes or no? What does this indicate? Error is less. You can also see that my few red spots are lying on the blue line. Error is less in this. So, in this example, can we apply the linear regression? We already applied, but is it good to apply linear regression? Then Maria will tell me, yes, sir. Why? Because our accuracy, we are getting it good. Yes, we agree that 100% accuracy is not there, but we are getting more accuracy than our previous example. Which example? This today's sales data, this data. Okay, comparative to this, our that example is suitable for simple linear regression. So how you are going to decide whether my simple linear regression is applied or not, should be applied to a particular data set or not? Can anyone answer? I'll give you 1 minute to think how we will decide them. The answer is in front of you. The answer is in front of you. Okay, Madhya is telling about size of data. Okay, let me clear your doubt, Madhya. See, if I decrease the, okay, you're talking about the entire data set. That is not the matter. If I change my this 200 rows to 1000 rows, 2000 rows, 5000, then also it not happen. And test data, if you think that after changing test data to let's say 20%, okay, something will change. Let us go ahead and check. Okay, now you see that points are increased. Why points are increased? Of course, I have done here 20%. Now. 20% in test data means this is my test data visualization. 20% point are there. 20% of 200 rows means how many rows? 40 rows, 40 points. And how many here are remaining? 160. Still, I can see very much scattered behavior is there. Still, I am not able to get the good accuracy. Only 2 points are coinciding, and 3 points are close to this. Okay, I'll keep on doing this. I can keep on doing this experiment. I can do it 50-50 also. 100 points, 100 points. Okay, 100 points, 100 points. See, 100 points in training data, 100 points in test data, 50-50. Then also you can see that model is not. What you will understand? What you will understand? This particular data is not at all useful for my data linear regression. Okay, everyone now note it down. I'm telling you the steps for deciding when to apply linear regression or not. First of all, any kind of regression, linear regression or polynomial regression, is applied only when we have continuous data and we want to predict some data. Whenever we want to predict some data. Currently, we are having sales data and we were with the intention of predicting tomorrow's sales. This is the sales data of today, 28th of May. I want to predict sales data of tomorrow. That's why it's suitable to apply the linear regression. First step is done. Correct or not? Okay, my first rule is we should have a continuous data set and our intention should be predicting the data set, not classification. Predicting the data set. All right, first step is done. Then why still we are not able to apply linear regression? Then it comes to the second rule. Write down everyone. Second rule. Guys, can we visualize the data set first? Can we visualize the data set first? Yes. Before training the models and everything, if you visualize the data, clearly we'll understand data is too much scattered. Yes or no? Do you guys agree or anyone has any point of objection? You can tell me frankly. See, instead of going all these things, if we directly visualize the data first, automatically we will understand na, data is scattered, we cannot apply the linear regression. Yes? Lavan is telling not understand. Which point you didn't understand? Simply, I told that for applying regression, there are two rules. First rule is compulsory, you need that regression is applied only when you need to predict something. Our sales data, why we analyze sales? Sales means what? How much product I'm selling. Why we analyze sale? Because to predict how much tomorrow I'm going to get the sale. Correct or not? So this is the prediction. That's why linear regression will be suitable, first of all. What is the second factor that we need to check? Second factor is how much data is scattered. If the data set doesn't have linear behavior, we cannot apply linear regression. Simple logic.